Assalamu alaikum. Welcome to the next lecture. We'll be continuing with the previous class that we have now seen. The equations will be delta pi will be equal to 0 and delta qi will be equal to 0, and we have defined that delta pi will be equal to pi specified minus pi calculated, and where pi calculated is equal to pi this, where we have dropped this calculated and we have assumed that pi will be this, and it is this function of deltas and voltages. Similarly, for this case, this Qi calculated is Qi function of deltas and voltages. Here also we have dropped a CL over there. So these are the actual equation which we have. So I'll first see what does this mean. This delta Pi is actually these equations. That means first let us define it like this. Delta Pi is equal to 0 means delta P2 is equal to 0. This is one equation. Delta P3 is equal to 0 is another equation. That up to delta Pn is equal to 0. These will be the n minus 1 equation. Similarly, delta Q2 will be equal to 0 for delta Qi is equal to 0. Delta Q3 will be equal to 0. That up to delta Qn is will be equal to 0. These will also be n minus 1 equations. Total will be 2n minus 2 equations. So you can see it from here. Sorry. So these are different equations like this. And now, since this equation, that is Fi, where I can vary from 1 to n, I have represented this by one equation like this, and then this can be further simplified like this. Fi function of the variables delta Fi by delta x1, that means the function uh, having a derivative with respect to the first variable, that is the function derivative of second variable, up to the function, same function having the derivative of the xn variable. This is the last variable. So we'll use the same expansion and we'll get this. So that's delta pi, that's for this delta pi 0 plus d delta pi by d delta 2, because the first this variable is delta 2 into delta 2, plus d delta pi by d delta 3, because second variable is delta 3 into delta 3, plus dash is up to delta pi by delta n into delta n. So these are, that means delta pi's are derived, and they have we are taking the derivative of delta pi with respect to the deltas up to n. Now we take the derivative of delta pi with respect to voltage, the delta pi by delta v2 into delta v2, delta pi by del v3 into del v3, delta pi by del vn into delta vn is equal to 0. Similarly, this q, delta qi naught plus delta qi by delta 2 into delta 2 plus delta qi by delta 3 into delta 3 up to n variable, and then this voltage reactive power is reactive power derivative is taken with respect to the voltages from v2 to vn. So these two equations can be put into single this matrix form, and in one matrix you will see they will be shown like this: delta pi, delta qi. In earlier case you will see that we have only one variable like this Fi. Here we have delta pi, delta qi, then two variables delta, you can see it from here, delta pi by delta 2, delta pi by delta 3, that is up to delta pi by delta n, then delta pi by delta v2, delta pi by delta v3, that is up to delta pi by delta vn. Similarly, this delta qi by delta 2, that is up to delta qi by delta n. That means qi will have to be taken the derivative from delta 2 to delta n. Similarly, derivative of the reactive power from v2 to vn. Then this will be d delta I and delta I and delta vi. So this actually this expansion of this equation. Here we have the function which is calculated at f is we can say the initial values, then the derivative of the function with respect to all the variables, and then the correction of the variables, or we can say variables multiply, it will be equal to 0. Same thing is done over here. You can see this is the function at initial value. This is the derivative of the function at all variables. The first function is delta p, and the second function is delta qi, and then the variables. You can see correction in the variables of variables that are to be multiplied over here. So expanding this further a bit, where I can take the value, this I has the value of 2, 3 up to n. So this delta p2, delta pi will be actually delta p2, delta p3 attaches up to delta pn, and delta qi will be delta q2, delta q3 attaches up to delta qn. And this delta pi has to be expanded like this. It will be equal to del delta p2 by del delta 2, del delta p2 by del delta 3. This pi is I am expanding this for different values of I. Then delta delta p2 by delta delta n. So this is for this. Then delta delta p2 by delta v2, this is p, delta delta p2 by delta v3, delta delta p2 by delta vn. Here in the numerator you will see all the function will remain the same. It will not change. That is, here the function is the p2, and variable will change from the first variable to the last variable. Here the first variable is delta 2 up to delta, and then the v2 to vn. Similarly, then delta p3 with delta delta 2, that is up to delta delta p3 with delta delta n. Similarly for this, that means this same function will be now derived derivative with respect to v2. This can go up to this the function pn. Then this function pn delta pn will be derivative with respect to delta 2 up to delta n, and then v2 up to vn. Then comes the reactive power. Reactive power is derivatives are taken in the similar way as that are taken for the real power. Then this delta delta I will be equal to delta delta 2. This will be delta delta 3 up to delta delta n. This is the expansion of delta delta I. Similarly, delta vi will be delta v2, delta v3 dashes up to delta vn. So this is how this can be formed. This matrix, that is a derivative matrix, is known as Jacobian matrix. This is the value which is calculated at the initial value, and these are the values which are to be calculated. So I can write it in this term. Okay, first I have to simplify a bit more because first we'll calculate this delta delta pi divided by delta delta g, where g can run from 2 to n. I have just to write it here, g, just to differentiate it from I. So this will be equal to delta delta pi, delta 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 by delta g into delta pi. So this pi will be actually delta pi will be equal to pi specified minus pi calculated. We know that pi specified is a constant value, and pi calculated is this value, which is equal to pi, which I have already told you that we have written this equation to be equal to pi, and we have dropped this value calculated. So pi specified is constant. When we derived it, when we take a derivative of this pi specified with respect to this delta or any other, it will be 0, and this will be delta pi by delta pi by delta delta g. I will write it like this. So similarly for other cases, so delta pi by delta vj will be equal to minus delta pi by this delta vj, delta qi divided by delta delta j will be equal to minus delta qi by delta delta j. Delta qi by delta vj will be equal to minus delta q by delta vj. So I will put these equations in this matrix. So here deltas will be replaced, and here we'll have minus, because all the terms will have minus, that will come over here. So our equation will now become like this. Delta pi delta q are minuses here. This will be delta pi by delta delta 2 up to delta pi by delta n, delta pi by delta v2, derivative up to delta pi by delta vn. Here one more term is written here, actually delta pi by delta v2, delta pi by delta v3 up to this. Similarly, delta qi by delta delta 2, delta qi by delta delta 3, derivative up to delta q by delta delta n. So delta q by delta v2, delta q by delta v3, derivative of delta q by delta vn. This is equal to 0. So I can call this term as g11, this term as g12, this term as g21, this term as g22. So I can simplify it in terms of writing like this: delta p delta q, delta p delta q itself represented pi and qi. So I have dropped here I and I also. but I hope that you will understand this. So here this is J11. J1 is this matrix, that is the derivative of the real power with respect to deltas is this will be equal to delta P by delta delta. So J12 will be equal to derivative of the real power with respect to voltage, this will be delta P by delta V. Similarly J21 will be derivative of the reactive power with respect to delta, that is J21, that is delta Q by delta delta 2, that is J21. J22 will be equal to derivative of real reactive power with respect to voltage, that is delta Q2, delta Q by delta V. So it has been written like this. This is equation 10. I have just take this whole side to the right side of this equation. So this will be delta P by delta will be equal to like this. Here delta P is actually delta P2, delta P3 up to that is up to delta Pn and minus 1 cross 1. This will be the order of this matrix. That's only this delta P. Delta Q will be equal to delta Q, delta 3 that is up to delta Q1. This will be also n cross. Actually, this should have n plus 1. Sorry, not n plus 1, n minus 1 cross 1. This will be n minus 1 cross 1. I have written n cross, it is not like that. Please you try to correct it. It is n minus 1 cross 1, n minus 1 cross 1. This is also n minus 1 cross 1, n minus 1 cross. That means delta delta will be equal to delta delta 2 up to delta delta n. So delta V will be equal to delta V2 up to delta Vn. Here also the order will be n minus 1 cross 1. Now the important thing is the order of this matrix. That will be derived from this G1 and G22. Now the order of this matrix will be, you can see it from here. Now from here to here, P2 remains same, and this change, that means there will be how many terms? There will be n minus 1 terms. Here also you can see delta 2 remains the same. From here to here, you will see there will be again n minus 1 terms, n minus 1. So for this matrix, you will see that the number of columns will be n minus 1 and the number of rows will be n minus 1. That means its order will be n minus 1 cross n minus 1. Similarly, for this case, you can see P2 remains the same throughout this, and from V2 to Vn, you will see the number of terms will be n minus 1. Here also, from this point to this point, V2 remains the same, but P2 will change up to P2 to Pn. That means the number of terms will be n minus 1. So here also, you will see the number of columns will be n minus 1, number of rows will be n minus 1. The order of this matrix will also be n minus 1. This is very important. So for this case also, it will be n minus 1 cross n minus 1. This case also n minus 1 cross n minus 1. Now, important thing is that the order of the whole matrix. So G11 is equal to del P by del delta. It will be n minus 1 cross n minus 1. G12 is del P by del V. This is n minus 1 cross n minus 1. Here P will change and V will change. This will be del Q by del delta. Its order will again be n minus 1 cross n minus 1. G22 will be del Q by del V. Its order, this will be small del, that means derivative. That is the n minus 1 cross n minus 1. So here delta P is n minus 1 cross 1. Delta Q is n minus cross 1. That means here the number of rows will be n minus 1. Again the number of rows will be n minus 1. Column will be only 1. The total number of rows will be 2n minus 2. Column will again be 1. The order of this will be 2n minus 2 cross 1. Now you can see in this term the number of rows will be n minus 1. Here also number of rows will be n minus 1. The total number of rows will be 2n minus 2. You will see that in this case columns will be n minus 1. Here also columns will be n minus 1. That means total number of columns will be 2n minus 2. Same is the case for this. You will see that the order of this Jacobian matrix will be 2n minus 2 cross 2n minus 2. This is in the case when we have a system only having PQ buses except the slack bus. Here this matrix will also have the order 2n minus 2 cross 1. I hope you understood this. Now calculating this d delta V, because we are finally interested in finding the change in the delta. So when we take this Jacobian matrix to this side, it will be this inverse multiplied by delta P into delta Q. So delta V will be J inverse delta P, delta J is the Jacobian matrix. For general iteration, d delta R, delta VR will be equal to gr, that's the same value, inverse delta pr delta q, and then delta r plus 1 vr plus 1 will be equal to delta r plus vr, that's the initial value of this, plus the correction, this correction. So this way, this is usually done. The Noether-Raphson method is usually done like this, but important is to get these values and the Jacobian element. So here we'll see just how to calculate the Jacobian elements. We know the Jacobian elements will be delta p by delta delta, where here it changes from this 2 to n. This delta also changes for 2 to n. Similarly for this case, for this case, for this case. So again we are assuming, okay, before going into the system of calculating the Jacobian element, we'll first take an example of 5-bus system where bus number 1 will be a slack bus and load buses will be from 2 to 5. So we'll calculate its Jacobian first. Jacobian will be like this. You will see it will be J will be delta P2 by delta delta, delta P2 by delta delta 3, delta P3 by delta delta 4, delta P2 by delta delta 5, delta P2 by delta V2, delta P2 by delta V3, delta P4 by delta V, sorry, delta P2 by delta V4, delta P2 by delta V5. So this is the derivative of function P2 with respect to all the variables. We have variables because here we have variables since 2 to 5. It will be V2, V3, V4, V5, delta 2, delta 3, delta 4, delta 5, 8 variables. So we are differentiating this P2 with respect to all the 8 variables. Similarly for P3 function, P4, P5, then Q2, Q3, Q4, Q5 will be having 8 functions as well. That is P2, P3, P4, P5, Q2, Q3, Q4, Q5. And here we can calculate this is the J11, delta P2 by delta P by delta delta will be this, delta P by delta V will be J12, delta P by delta Q by delta delta will be J21, delta P by delta Q by delta V will be J22. This is the Jacobian matrix that we have to calculate for a 5-bus system having bus number 1 as the slack bus and all other buses are the load buses. Again you can see how many rows are there? 1, 2, 3, 4, 5, 6, 7, 8. How many columns are there? 1, 2, 3, 4, 5, 6, 7, 8. And then it will be 8 cross 8 matrix. You can calculate it from here. 2 into 5 minus 1, 5 us. That is 8, 10 minus 2, 10 minus 2. That's 8 cross 8 will be order. You can calculate all the variables also. Variables will be delta 2, which we have already calculated. Now, the calculation of in general calculation of the you can see this calculation of the Jacobian elements. We'll assume the same 5-bus system. That's why I have written a 1 to 5. Pi is equal to Vi. Summation j is equal to 1 to this, where I is equal to this. So let I is equal to 2. For we'll try to find out the first row and then others you can find. So P2 will be equal to, we'll expand this, V2, V1, Y21 cos of this, then this. So this you can just put in the value of I and j, you will get this equation. First, when I is not equal to j, it doesn't mean this I, it means when this I is not equal to this j, that means when the function is not derivated with respect to its own phase angle. So that's what is meant by I and j. So del P2 by del delta 3, you can see only this will be there, delta 3 is only here. There will be no delta 3, no delta 3, no delta 3, no delta 3. That means this will be equal to V2. This will be V2 multiplied by V3 Y23 cos minus sine delta 2 minus delta 3 minus delta 2 3, and the internal differentiation of this minus, that is minus plus. So this will be its derivative. So delta P2, this should have been delta 4. Delta P2 by delta 4 is not delta P4. Again, this variable is not, this constant is not equal to this constant. So in that case, to be equal to V2, V4, that is this V2. V2 is actually multiplied to whole of this term. V2, V4, Y24. Then we sine delta 2 minus delta 4 minus theta 24. This should have been delta 4. the internal derivative of this will be -1, and the derivative of this is minus cos. That minus that much will be plus. So in general, I can take it like this: delta P2 delta P2 by delta delta 3. I can say that delta Pi by delta delta j will be equal to Vi Vj Yij sine of delta I minus delta j minus theta ij. So in this way we can calculate it. Now when I is equal to g, that means when the function is differentiated with respect to its own phase angle, you can see delta P2 delta delta 2. You will see delta delta 2 is almost all in every function, but here it would have been delta 2, but delta 2 will cancel out. This will be V2 Y22 cos of theta 22. So this term will be equal to 0. This term will be there with some other modifications. It will be equal to V2 minus V1 Y21 sine of delta 2 minus delta 1 minus theta 2. This will be second term will be 0. This will be the third term, fourth term, and fifth term. I can take V2 as it is and then take the summation of these four terms. Only thing is that G should not be equal to 2. G should not be equal to, because that for that case it will be equal to 0. So similarly for delta P3 by delta delta 3 will be like this. G should not be equal to this. So in that case, when this I and this I are same, it will be equal to minus Vi. Summation of G is equal to 1 to n. G, where G should not be equal to I in this term, not this. In this term, G should not be equal to I. So Vj in this summation, rather Vj Yij sine of delta I minus delta j minus theta I. Theta ij. This will be delta Pi by delta delta I. So we have calculated delta P by delta delta. Delta when the function P is derivative with respect to its own phase angle, and when it is derivative with respect to other phase angles of the buses. Similarly, delta P by delta Vj, that is the derivative of the function P with respect to the voltage of the other buses, will be like this. Similarly, for delta Pi by delta Vi, it will be this and then Pi, because we are multiplying this by, since this is only uh, the difference between Pi and this summation is the absence of Vi. We multiply this by Vi and it becomes Pi, and we have to divide it as well. Vi. So this is it is delta Pi by delta Vi. Similarly for Q. So the equations, that is equation 2, 3, 4, 5, and these are used to calculate the Jacobian elements. Now Newton-Raphson method that we have to calculate will be doing it for the system which has PQ buses as well as PV buses. So in that case, let us again assume that we have an N bus system. The bus number 1 is the slack bus. PV buses will be numbered from 2 to M. That means total number of PV buses will be M minus 1. So PQ buses will be from M plus 1 to N. That's M plus 1, M plus 2 dash up to N. So total number of PQ buses will be N minus 1. So first we'll try to figure out how many variables we have to first find. So as we know that, we'll first calculate the voltage and phase angle. For P buses, we need to calculate delta only, because the voltage is already given, because V is given at every bus, and not every bus at PV bus. So we have M minus 1 variables for all PV buses, because M minus 1 will be the PV buses, and for PV buses we have to calculate delta only. That means there will be M minus 1 variables. Since all the PV bus P is given, we can make the same number of equations. Again, P is given for the all number of all PV buses, the same number of equations can be made. So this is here done. Similarly, for PQ buses, we need to calculate delta as well as the magnitude of phase voltage. That is, the total number of variables will be now 2 into n minus m, because PQ buses are n minus 1. Since at each bus P and Q are given, that means same number of equations can be made. So the total number of variables or total number of equations will be now 2 into n minus 1 plus m minus 1, that is 2n minus 2m plus m minus 1, that is 2n minus m minus 1. This is the total number of equations, and the total number of variables will be same will be the number of equations. So variables will be What are the different variables? In the previous cases, we had delta 2, delta 3 up to delta n, and we had V2, V3 up to Vn. But here, deltas will be the same, but the voltages will change because the voltage for PV bus are given from 2 to m. That means the voltages for PQ buses we have to calculate. That is Vm plus 1, Vm plus 2, that is up to Vn. The total number of variables will be n minus 1 and n minus m. That is 2n minus m minus 1. So here also from this way you can also calculate the value of the number of variables and the number of equations itself. The number of equations you can calculate like this. Equation to be formed P2 to Pn, it is given for all the buses except slack bus. PU buses it is given, PQ bus it is given, that's n minus 1. And for PQ buses only Q is given, that means those equations can be formed. They are equal to n minus 1. So the equation will be, total number of equations will be n minus 1 minus. So now for this case, this is very uh, simple to write the equation. The only thing we have to keep in mind the different variables. So as the earlier case, I can write now directly delta P2 that is up to delta Pn. But here earlier we have written delta Q2 up to delta Qn. But here we have, since the Q is given for the this PQ buses only, so it goes from delta Qm plus 1 that is up to delta Qn. You can see that from this point to this point they are n minus 1. From this point to this point they are n minus m. So total order of this will be 2n minus m minus 1 cross 1. This will be the order of this. Now for this, that is G11 delta P2 by delta 2. That means this P2 has to be differentiated with our variable. First we'll differentiate with respect to deltas only. That's P2 to delta 2 up to Pn to delta 2. That means this remains the same. This matrix G11 n minus 1 and then it remains the same. Now here delta P2 by delta Vm2, we don't have to write Vm2 because here Vm2 is not is given already. So the variable is not Vm2, variable is Vm plus 1. So it will be delta P2 by delta Vm plus 1, delta P2 by delta Vm plus 2, that is up to delta P2 by delta Vn. Similarly for other variables like this. So delta Qm plus 1, because delta Q2 is not given, Q2 is not given, Q is given for the PQ buses, and PQ buses start from m plus 1. So I have written it delta Qm plus 1 divided by delta 2, and then delta Qm plus 1 divided by delta 3 up to delta Qm plus 1 divided by delta n. So delta Qn, that is up to delta Qn by delta 2, that is up to delta Qn by delta n. Similarly, the differentiation section of this reactive power with respect to voltages, and we know that these values are only from m plus 1 to n. These values are also from m plus 1 to n. So I can say that the number of the number of columns in this case, you will see that will depend about the number of variables, and the number of variables in this case will be delta 2, delta 3 up to delta n. That means n minus 1. And the number of rows will depend upon the number of equations. The number of equations, P's equation will be again n minus 1 because P is given for 2 to n. So it means the order for this case will be n minus 1 cross n minus 1. For this case, you will see that P2 remains the same, the order of this. That means the columns will be the number of voltage variables, and the voltage variables will be n minus m. The columns will be here n minus m. Rows will be same as that of the equation, that is P equation is n minus 1. So the order of this G12 will be n minus 1 into n minus m. Similarly for this case, you can see that the columns will be same as the number of rows, deltas, and deltas are n minus 1. So it will be n minus 1. The rows will be the number of reactive power equations, they are n minus m. That means the order of this matrix G21 will be n minus 1 into n minus 1. Similarly for this case, you can see the equations will be Q equations will be n minus m, and V variables will be n minus m. So number of rows will be n minus 1, same as the number of columns. The order of this will be n minus m into n minus m. So the total order of this matrix will be 2n minus m minus 1. You can see that here the rows will be n minus 1, here the rows will be n minus m. Here the columns will be n minus 1, here the columns will be n minus m. So the total number of rows 2n minus m minus 1, here 2n minus m minus 1. Here also deltas will be n minus 1 and voltage will be n minus m. The order of this matrix will be twice n minus m minus 1. I will stop over here and I will continue in the next class. Thank you.